Well, matter is made out of relatively simple building blocks, basic particles like electrons and protons, and they're governed by pretty simple rules, the rules of quantum mechanics. The thing that's amazing is that when you have many of these particles, many electrons, you can have phenomena which you would never expect to emerge out of these collections of particles. And so the discovery of topological insulators is a discovery of a new class of emergent phenomena that can happen that governs the way the matter can conduct electricity. Well, so the theory of materials was developed in the 20th century, and a lot was understood at that point. But what we've learned in the last decade or so is that there were features of the electronic structure of materials that nobody had ever thought about asking about, and those features are things that one can study and predict. Using modeling and computation, and that's led to a huge enterprise of interplay between prediction and computation and experimentation, and that's led to a huge amount of activity. Making a quantum computer is one of the grand technological challenges of the coming century. I don't know what the best way of doing that is going to be, but there's a possibility that the features of topological insulators could be a way of doing that. And my attitude towards this is that the goal of making a quantum computer provides a goalpost, a goal that one can try to strive towards. But along the way towards achieving that, there are many very interesting scientific questions that have to be addressed and answered. And what often happens in the course of doing that is that you come up with things that you wouldn't have thought of otherwise. And so I view this as a very productive endeavor, and it's also a lot of fun.